So I'll actually quickly go back to this slide, and I really liked when Steve said, we are seeing Violin after a long time, right? Violin is back today. And the reason you had, some of you who are familiar with the Violin, you would know that we were the leaders in 2013 in terms of the flash storage. Nobody could give you the IOPS at some millisecond latency as we could. But as flash started to get more adopted in the mainstream data centers, we started to lose out because we didn't have some of the features to make us a viable solution into the primary data centers. So tier 0 we conquered. Tier 1 is where we started to struggle. It has been 2.5-year journey to come back with the software feature married to the same tier 0 platform, and I'll talk about how it has also changed, to come back and present all these features really married to the flash software that we rolled out several years ago, which is a very stable platform, and present to the and give to the user confidence that this is not only about the performance anymore, it's also about all these features. Because without this, and you were right that all those features about 0 RPO, 0 RTO become very relevant when you are into the primary data center. How many workloads you can pack? I can sit and argue all day that 250 or 300K IOPS is good enough. But this is VMworld, and we know more and more densities are being packed into the rack. So performance envelope also has to be large enough. And how do you do that? How do you get to the million IOPS with all these features? Was an interesting question that we answered as we went around for the development of 2.5 years. So so this is where I would be focusing a lot more. So this is new to Violin. Violin of 2013 was leader again in the tier 0 with the base SAN management feature. We didn't have any one of these DR features. Now it is there, integrated tightly with our platform, and I'll walk you through how we have married to our platform, because that's very important. But before we start, let me, the first 2 slides I would be using to set the context as to where our key IPs reside. And then we'll start going into each one of those sections, one section at a time. So flash array. This is what Violin released. This is over 9 years now. And the beauty of this architecture we'll talk about in 2-3 slides down the line as to how this has allowed us to retain the same chassis, but keep on evolving the individual components to drive up the IOPS and the latency. So this is where all the hardware IPs go in. Then married to this is the Concerto OS that we rolled out. And this is where a lot of work has gone in to bring in the enterprise features tightly integrated to the flash platform that we had. And then finally, connecting them all together, this is Symphony, which is a single pane of glass management software for multiple Violin arrays. Doesn't matter which generation you're playing with, to manage all of them. The next slide, I'm going to have just one level more click on each one of those components to start building a little bit more on what we have. So those of you who are familiar with Violin, this may not be new. So we have our own equivalent of SST, it's just a VIM. So we have our own flash controller, and there could be up to 64 of them, and there's a slide coming up in our 1.3U box, managed by industry's first 4-way HA flash optimized RAID controller. And the traditional RAID 5, RAID 6 don't work with flash. You have to have certain kind of things going on over there to make it work really friendly with all those flash devices that you got. The garbage collection and all those things need to be managed to give the experience of the sustained latency when the garbage collection kicks in. Heavy writes are going on. How do you make sure the reads don't suffer the latency? A bunch of patents have gone into this area. And connecting them all together, so this is what we call as the flash fabric. Connecting them all together is the management controller that is here where our data management software lives in. So if you take a close look at it, it is important for us to own this entire stack so that software running over here is intimately aware of what's going on in these flash shells. So we have a tighter integration over there so that we can drive the garbage collection the way we want. We can suppress the latencies because we manage them as a pool. Full control. There is a tighter integration between the flash controller and the software land up above. We communicate, bidirectionally.
Can I ask you a question about that?
Yeah, go ahead.
If we go back 5 or 6 years when you were the first company to be bringing out flash products, it made sense that there was some benefit to the fact that you engineered the VIMs and up the stack. However, as we move into different types of flash and we get more MLC, TLC, 3D NAND, and whatever else comes afterwards, how are you going to trade off the fact that you'll have to do engineering work on every single one of those types of flash or non-flash products compared to vendors who've literally taken off-the-shelf drives from a vendor that they've partnered with and put it into an array and used it without having to do a significant amount of hardware engineering around that.
Also, some part is NVMe now is becoming quite standard.
Exactly,
everywhere.
and
So
obviously with the NVMe, the gap that you have with your Vim and upwards technology could be perhaps classed as being not as much of an opportunity or as a differentiator as it possibly used to be.
Yeah, absolutely. So you asked a very good question that we get, faced more often, and I'll tell you very honestly, if I have to start today, and I know my window is very small, that's what I'll do. I'll go over and off the shelf and buy it, but then I will not get the benefit that I get over here. What kind of benefits we get? So this platform is mature now. It's all is in there. And in the next slide, I'll show you that each one of them can be individually involved. All those flash controller that we have written with our magic for the read height, write height, they're just there. As the new NAND lithos come in, which, what we rolled out in 2013 is not the same NAND litho that is shipping out today. Since we have this platform baked, if you go down and start focusing on each individual component, your work is narrowed down to just getting that right. You need far smaller team. And your scope is just to make it work with enterprise workload, right? And you get the flexibility to marry it with the software up above, which you don't get today. But if I have to start this development work today, it's a significant work to get it right, to get it stabilized, to get it into a situation that I can be rolling out the subsequent NAND lithos, at a quick time. But that is what we are able to do today.
So just to qualify that, you're saying that because you've done the level of development that you have,
Yes.
for you it's not a significant issue to support new NAND fabrication types?
And yes, and the proof is in the fact the way we are rolling out the NAND lithos, fairly quickly, as we go, 1 terabyte to 2 terabyte, A19, standard C. So we are doing it very, very quickly.
Vikas, if I can add just a couple more comments, because I think this is a question we get asked a lot. So I think it bears, I'm sure the audience has a lot of questions on that. I think number one, it's probably important to note that even the vendors who are using an off-the-shelf form factor like an SSD still have to do a significant amount of characterization, right? Because even though they share the same packaging, right, as the lithos change, the endurance, the read-write performance, and all that changes very quickly, so it could significantly impact the array-level performance, right? So I would probably argue that within any given generation, it's even challenging for a traditional array vendor to be significantly multi-source just because things are changing so quickly, right? I think as we continue to go down through smaller lithos, potentially the write endurance and of the underlying media goes down and the error rates go up. If anything, it's more important to intimately manage the flash. So wasting, so things you can gain, the key points of our architecture is that we have a global flash translation layer. We wear evenly, we stripe all writes very evenly, and we have things at the array level that prevent sort of siloed pockets of over provisioning. We can do hot-cold separation at the array level, right? So if you believe that as the lithos continue to shrink, right, that error rates are going to become higher, endurance going to goes down, I think it's actually more important to have those efficiencies, right? I think then as far as NVMe goes, the NVMe interface won't deliver some things, again, like the benefit of a global flash translation layer, right? Because they're still siloed devices. And I think the writing is very, very clearly on the wall that NVMe or an NVMe-based fabric is clearly the future, but that's still an evolution or journey that's going to take, several years and generations, and people have to implement new sheet metal, new JBODs, completely new designs. And I think the industry has definitely had, some mishaps in the past over PCIe switched fabrics. So it's not a trivial thing to do. So I think even though they're off the shelf or purchasable from third-party vendors, that technology inflection is definitely not straightforward. And again, that's what this team has been doing for the last decade to harden, build, and develop.
Yeah, and snapshots are important. Standing as of today versus standing 3 years from now, right? Standing 3 years from now, all those things in the ecosystem make catch up. We may also change, but as of today, if you have to deliver the true value of flash with the kind of latency and the sustained behavior that you're talking about, you have to put together the platform the way this has been done. So that's why there is nothing, when we talk about million IOPS, we talk about with sustained millisecond latency also, because we have been able to marry all of them together. NVMe is a good question. Probably it's the future, but think about it. An NVMe drive dual ported. These these drivers are triple ported. So kind of an enterprise level resiliency you can build, or we have built over a period of time, does not exist today. To take a system and make it enterprise ready, if you start from today, working off the shelf hardware. 3 years from now, I completely agree. Things may change. Ecosystem may catch up.
So let's just separate the agility question then from, you said that you think you're agile enough to be able to keep using that technology as it comes up. What about cost? Do you think that this gives you a cost advantage, or do you think the fact that other vendors can take commodity components and can produce a product that's more cost effective than you could produce?
So very good, excellent question. So think about it. In this model, what do we buy? We buy only NAND chip. So our cost is any day going to be...
Yes and no, because you're buying other components and you're building other components.
Agree.
So costs associated with that. You don't
just
put straight NAND into your product, into the...
Right, but overall, if you put together the cost of this device that we have over here, over doing X kind of performance, each one of them can do 250K and all those things, and compare it with the triple port and with what's available in the market, we are at a significant advantage. And Andrew can comment.
Yeah, a couple things is we don't have nearly as many handoffs, right? So if you purchase an SSD, yes, there's always the argument that it's an off-the-shelf component and they have the benefit of scale. But at the same time, they have to make a living, right? So there is certainly a markup there. So you're paying a double markup, right? You pay the markup that the SSD vendor charges the enterprise OEM, and then the enterprise OEM charges a markup on that as well. And I think that's the readily available example is always if you look at a FRU for your enterprise array versus what you should be able to buy an SSD for on Amazon. I mean, there's a ginormous spread there, right? So the cost, I think we absolutely think that the cost issue, if anything, our architecture gives us a cost advantage. And again, nothing is wasted, right? Because you have redundant and you have unnecessary features by going through an SSD form factor through an HDD protocol, right? The difference, as Vikas indicated, between our architecture and an SSD and a SAS expander going through a SAS chain through a traditional storage backend, it's not cosmetic. It's not a packaging exercise, right? So in some cases, our VIMs do significantly more than an SSD, and in some cases, they do less because everything is distributed and coordinated among this entire end-to-end architecture. So we would argue that we have less wasted content in our system because we built it end-to-end.
So street price today would be about what? Bear in mind there are people who are talking about $1 a gig.
Yeah.
Tejar with their new IntelliFlash are talking about $0.50 a gig.
Yeah.
Now that isn't necessarily targeted at the market perhaps that you're targeted at.
Sure.
But people are very focused on price a lot of the time, and they ignore the fact that it might have lots of other things and clever. They go on price. So if you're not in the right ballpark, people
sure. So yeah, when we announced the flash storage platform at the beginning of the year, right? The number we gave out at the time, that's probably still the best. That's probably the number I can get at least here. But we certainly anybody who would like to inquire, we can give more detail. Was $1.50 a gig effective at that time, and that was 6 months ago. We can certainly do better than that now. So
right, because that was something that if you go back 3 or 4 years ago. I remember being told, don't worry about the price.
Yeah.
It's expensive, but we're fixing a problem that nobody else can fix, so you're going to have to pay.
And
whatever.
we don't rely on that premise anymore.
That was never really a great message.
And at the time we announced that price point, we were the first. Back then, everybody was just, the $2 was the milestone. Yeah. We announced the FSP, it was $1.50, and again, we're competitive with market.
So I'm not sure whether that comes across as a strong message in your marketing. Mm-hmm. Okay. That's why I had to ask the question.
Valid point. Yes.
Very good. And it's treated from an economies of scale perspective when it comes to the dollar or 50 cents a gig, because you say, all right, sweet, and you don't have to have it fully populated. I'll just buy a small portion. Whoa, then that's $4 a gig. Okay?
Yeah, absolutely.
So in a fully populated type of chassis, but the go-to-market around the elegance inside the solution, how it's able to do things very characteristically, like we're able to drive every possible IOP and with the lowest possible latency. But sometimes people are like, can I get 80% from somebody else for 20% of the cost?
If it's cheaper,
and that's kind of driving that home. That some people just want just good enough, and in other circumstances where the almighty dollar dictates what they're doing as an organization, then they'll pay through the sky to ensure that they're getting their absolute guarantee. But those Fortune 50 and organizations that have that absolute requirement are fewer than the common marketplace that just has a need of, I really only need 5,000 IOPS at the end of the day. But if I can get it really fast, I'll accept it in that footprint.
Who is your target market for this? Mid-level, enterprise?
It's definitely in terms of the starting target. The framework that we sort of tend to draw is sort of a pyramid. This is a gross simplification, right? As again, we started off in the tier 0, and the easiest explanation for that was formerly the domain of short stroke solutions, right? And then if you talk about tier 1, I think dominantly as the market continues to penetrate downhill. And again, we believe flash has a long way to run in taking over the market, but it would really be the first and richest targets would be the legacy frame array franchises, as well as the high-end modular mid-range and ones that are pretty much heavily hybridized today.
Yeah. So we started. Sorry, go ahead.
I'm sorry, I'm familiar with like the EMC product line.
Yeah. So
if I'm talking about VNX and going into like the 10K VMAX, or I'm talking about 20, 40K VMAX, where I'm
so certainly the VMAX class platforms, we would say even down to the 10K for sure are targets for this, and even customers who for reasons have bought a higher end VNX systems also. In the case of the IBM parlance, it'd be like the DS8000 franchise or like a Hitachi VSP. So we think those are absolutely very, very ripe targets for a flash-based solution, because people bought them for the resiliency, for the capabilities, and the big missing ingredient again was that no one in a flash space had native data management, data protection capabilities that could also meet the requirements of those franchises, right? And so the problem is, okay, Flash can help you transform your business, but you shouldn't have to transform your IT environment in order to accommodate Flash, right? But from a target standpoint, that's where we're going after.
Now we're going to dive deeper into the data management capabilities, as well as how you handle metadata handlings to augment some of the challenges that other people have, whether they're past players or even current day players with mature solutions.
We absolutely can.
So we absolutely can, and I'll try to cover that as well. In that time is short, but we'll try to cover that. And there is another session coming up with a longer 8-hour thing. I'll be happy to walk any level through with that one. Okay, so quickly moving up. So this is the software stack that we put together, and I've seen the layers which constitute the software stack, to highlight what we are delivering and how we are delivering, and the importance of keeping them layered so that we can change them individually. So we are carrying the modularity approach from down below to up, so that any of these could be modified independent of that to contain the risk and evolve the platform. Same thing over here. So we can keep on adding more targets tomorrow, or keep on adding more data management features here, or do several different things. So quickly walking up. So we, at the very down, we have the flexibility where we can either, so the two product, so we didn't introduce you to the products, but the two different product lines we support. One is a 7300 self-contained 3U box, 64 VIMs over there. Depending on the density, you could have up to 70 terabyte with the current generation, 140 with the next generation, all in 3U. So that's completely packed, fully loaded with all software features. And we have another one, 7700, where it's a scale-up solution. So you can keep on adding the shelves and all. So in one, we use the VTMS, which is our driver, which keeps the handshake going between the software stack up above and the hardware down below. So this goes back to what is the benefit of owning your own hardware. The benefit is we can tie in the hints that we need to send down to the flash layer, so that certain decisions could be made at the flash optimized rate controller. That hey, these many blocks I don't need to use anymore, so go ahead and don't do the right amplification, just get rid of them. Or these are the block size that I'm using, so keep it prefetched in your memory so that I can get it back as quickly as I want. Or you have 64K block of IO coming in, I can distribute and dissect 1K each across 64 VIMs, 60 VIMs, and get that kind of performance parallelized. Those are the facilities that we will not get if we use standard SSD, because then you're reliant on the SSD vendors, block sizes, and so forth. So going back above, we have the downstream. So this one does the arbitration as to which layer the IOs are going to go in. And then up above, you have the basic LUN types, whether it's a thick LUN, thin LUN, or a dedupe LUN. And there are services which make deduplication LUN happen. So as you can see, transforming from here to there, or there to there, or back, is basically an operation that you can independently carry out. So they are not mismatched. They could be completely independent data path. And then driving all of them is the data set features on top of that. So
Deduplicated LANs are also thin.
Yes, they're also thin, and they also are compressed as well. So we just refer to dedupe because that's the most common, but they are thin and compressed.
Yeah, so this is a classical thin LUN from the yesterdays, that physical allocations happen later, and this is the deduplication LUN where everything gets deduped. And then on top of that, you have the data management services. So we have almost all of them have been shown that Andrew covered in the previous slides. We have a continuous data protection. So you get ability to roll back to any point in time. And we have replication. So this is where we provide full set of replication features, starting from continuous replication to periodic replication. And you have, bunch of services that go with the replication for throttling, for encryption, WAN optimization, and so forth. And then you have sync mirror. So this is where you have, the local protection from the local disasters and, sort of things. Then snap. And there are others. There wasn't enough real estate to cover that, so I'll go on to them as we move on to the next slides.
Does others include integration with third-party services for backup, because Snap does not equal backup historically in the industry?
Yes. So we have host side things also coming up. So that coordinates with. So we have a set of scripts that go into with the third-party, backup appliance. Mm-hmm. So you can put it in the pre or the post. When the pre kicks in, you go ahead, take the snap, mount it to the backup server. Once the backup is done, you unmount it and you get done with that. So, yeah. And then at the very top level, we have the interface, FC, iSCSI, and so forth. Tying them all together is the host side thing. So this application server, or we are into the VMware world, or the VMware side of the things. So we have the host side agents, which allow application users to drive application consistent snapshots or application consistent replica. So, typically, if you have the crash consistent snapshot, there's no guarantee that you will be able to go back to a pristine state of the application. So this is where you need the application consistent snapshot running on the host side. So depending on the bare metal or VMware, you need a different kind of approach over there. So we have full suite of that stack, multiple applications supported. And then tying them all together is Symphony. So one stop, and you can manage multiple boxes and multiple different aspects with one console. You can configure the alert mechanism, the reports, and it gives you a variety of reports. So we will not have time to run through the demo, but it's pretty extensive. We have several YouTube videos out over there as to how intuitive it makes the management of the flash arrays in the data center.
Did I miss something? You never mentioned VMware Hyper-V integration or whatever.
Okay.
Yeah, vVols, VAI, other providers, whatever.
Yep. Very good point. And I should correct that one. You're right. We should put that. So we have 100% VAI compliance. So we are fully we support VAI across all the LANs. Any one of them you can do that. All four primitives are done. We have the SRM. We have the the SRM plugins so that we can drive the consistent application working in conjunction with the hypervisors. And we are working on the vVol. So vVol has not been announced yet.
And we also have vCenter plugin.
We have the vCenter plugin, for the management. Those standard things are all there.
And you can run Fiber Channel, iSCSI, and InfiniBand all at the same time, or is it you can choose one versus the other?
It's one versus the other. So there's nothing technologically that is preventing us from supporting a mixed mode, but at this time we've only productized single mode, and we have not yet productized the ISER. So right now, when we rolled it out, it's 16 gig fiber and 10 gig iSCSI. We have the capability to do ISER. We're also looking at some RDMA types of access, and we do have the ability to support mixed mode, but we haven't productized it.
So if you were to do a Fiber Channel or iSCSI configuration, then the alternate ports would possibly be used as part of your CDP and or your sync type of scheduling, at least from a physical architecture standpoint, in order to provide that channel to communicate?
So we have a separate dedicated ports for replication. So that's not taken away from the user ports, user facing PCI ports.
So I don't want to direct the conversation too much beyond the technical piece, because I know most of these guys are really into the knobs. But from a practical perspective, from a high level, I'm getting the value prop of Violin memory. Mm-hmm. Cool solution. I have to ask the question, what if I have to go into the office of my CIO, CTO, and say Violin versus EMC? Mm-hmm. Stable company versus a company with a stock price of sub $2. What's the value prop?
Okay, so I'll go the technical one, and then I'll let Andrew. So when you think of Violin,
let me make sure I preface this, because we're competing against VMAX, 40K, 20K. These are major investments. Mm-hmm. So from a perspective of an engineer, I love the technology, and I need to make the sale to my CIO, CTO, that's kind of setting the stage. What would make me stick my neck on the line and say, trade study came in, value prop of the solution is strong enough from a technical perspective that we take the financial risk on a company that hasn't done well financially.
Sure.
Yeah, agree. So and a very good question. So it has been looked at two different angles. First is, with Violin, do you get everything that VMAX does? Number one. So you have to have because VMAX has been gold standard for a long time because it provides you with the availability and the RAS features and the software features to give you the peace of mind. So with the Violin, do you lose any one of them? So that's one thing you need to answer. And then second, what is the benefit I get? If it is apples to apples, the same thing, then I don't gain anything, right? So what is in? So so far what I have gone through is to highlight that you don't lose any feature with Violin. Okay. Now, the technology-wise, as to what you get with Violin, there was an interesting picture that Andrew has put in his slides, 6 racks of VMAX versus half a rack of Violin. What do I mean by that? That means the density, the performance, and the consistency, because VMAX workloads are typically in the transaction-driven workload. The latencies are the king, right? With the sustained performance is the king, right? You cannot have the spikes. This is what you get with this one.
So I think then there's the business angle, because your business folks are still going to say, yes, I hear that. That's very well and good, but still, I mean, I'm taking a certain amount of corporate risk by going with a vendor like Violin. So I think there's sort of two key points that I think are not commonly well known about Violin, but definitely want to make. Is one, we're a publicly traded company, and so obviously that can work against us because certain things are visible, but I also urge everyone to consider that we are very transparent and that our financials are there. So if you look at our balance sheet and you look at our burn rate and you look at our expense profile over time, right, we clearly have enough headroom to run. So I think there are companies that, because they've bought into certain messages, have been willing to take larger bets on companies that don't offer that same level of corporate transparency, right? Again, all of our financials are fully out there, and anyone can do the math. We encourage them to do so. We've easily got several years of burn in the bank that can take us through to growing to profitability. And that isn't to say that in the past, particularly in the wake of the IPO, over a year and a half, 2 years ago, under a different management team, we had some missteps, but the company is well and effectively run, and you can verify the numbers for yourself. Then it also, I think, becomes the notion that when you have a technology inflection like what we're seeing in the marketplace today, do you go with the disruptor? And I will say, with credit to EMC, they're a very stable company. It's like no one got fired for buying IBM, and I think they've actually done a very good job so far in terms of trying to self-disrupt or recognize that Flash was threatening their legacy franchises. But I still think at the end of the day, balancing a portfolio, balancing multiple interests, and trying to figure out which pieces of the federation to go with and not. I think a product level stability or a technology level stability versus a company that, again, is singularly focused on making this technology work and make this technology the most compelling solution for businesses in the future, and is run and driven solely with that purpose in mind, is something that everyone should absolutely consider.
So do you see yourself from a go-to-market standpoint saying we can replace your legacy array, or your legacy non-all-flash array, or do you see yourself starting to go ramping up against all the other all-flash array type solutions available in the market? Because that becomes a little more contentious. Also, as well, your strategy is, I'm going to rip out your old filers, I'm going to rip out your old VNXs and other legacy stuff like that. That's a very easy conversation to a certain extent. But going and saying, I'm up against all of these all-flash arrays, or I'm up against a VMAX, or certain types of the extremely high-end type of arrays, because we can do the transactions, but you're usually buying those systems because they can do transactions plus resiliency, and might not be the easiest target, especially if FICON, we're offering services for mainframe. Sure. Hey, and they're buying SRDF. They're buying a different story when it comes to a VMAX. So when people compare Extreme IO to VMAX, I'm like, what are you doing? It's faster. Yeah, I'm not buying speed. I'm buying so much more than just a little bit of speed. Yes. So I want to make sure where we're trying to position against versus all of the places in the market, because it's a really contentious space out there today, even.
So at the end of the day, are we saying that the Violin story, the roadmap, the architecture, is more in line with where the enterprise is, where you guys believe the enterprise is going to go over the next 5 years? Because these are typically 5-year investments.
Yes.
And your 5-year roadmap is fundamentally different than what your competitor's 5-year roadmap is.
Yes.
And you're trying to convince the buying center that obviously that your financials are solid for the next 5 years.
Yes.
And this is a solid bet for the next 5 years.
Let me take that a bit. I'm Amy Love. I'm our Chief Marketing Officer, also responsible for product management. Let me take it from this standpoint. We believe there's several reasons why IT professionals run into issues from their career perspective and also how they actually can catapult their careers forward. You run into trouble for data loss, security breaches, downtime. You can also run in trouble for missing a technology wave. And we at Violin fundamentally believe this is a significant tsunami technology wave that's happening. And those companies that have invested today in making the migration to all flash and a recognition of what Violin, the only all flash player out there today that can offer all 5 levels of data protection, those are the companies that 2 years from now are going to be the ones that are able to meet the increasing demands that are being placed on their IT centers while being able to have the superior performance. That's why, for example, we were just able to announce this last quarter alone 9 new either Fortune Global 500 or Fortune 1000 companies that have taken the bet that believe a company like Violin that has the full levels of data protection you need, availability and reliability, coupled with, to your point, a cash level position, given that we're a public company with more than $120 million in the bank, that allows us to make this migration to help our customers ride this wave, the tsunami wave of shift, is going to make a huge difference. This is going to actually propel IT players' careers when they make that move to say 2 years from now we're going to be at a competitive disadvantage if we refreshed on disk, because our competitors will have made that move to flash. And the player that can provide that capability for us today and has the purpose-built hardware software that will allow you to drive the market forward is Violin. And those are the ones who are going to see their careers propel, and we believe is very much going to propel Violin forward because of the strength of our financial position. You know, the markets are irrational, especially right now with what's going on in China and everywhere else. The markets are irrational. We're sitting on cash. Others are not sitting on cash. We're fully transparent on our investments and our spend. And so the customers have the ability to see how well run we are as a company and where we're taking it to move forward. So that's how I'd answer the business question.
So how are you supporting potential customers that are interested in possibly trying out your product? Do you do POCs or anything like that where you could
Yeah, no,
try it
absolutely.
out?
Absolutely. Customers interested, we certainly can support them through a POC. So we can have our pre-sales team engage with them. Certainly give them deep information on the product and capabilities. We have an extensive, again, pre-sales and professional services organization. They can also help them assess, their needs and make recommendations, sizing about what the product can do, and then certainly, if necessary, we do POCs. Yeah.
Okay. Yeah, because to what Keith was talking about too, I mean, I think it's a hard sell, it's a hard transition to bring something new in, and so being able to support that's important.
Yeah, and so you're right. So we have a dedicated POC infrastructure team, but we don't drop every box for the POC, right? So there's a proper qualification that goes in, and then as we make progress, we're continuing to build the references. At times the references help, and at times you have to actually have the technical debate first, and then let them try it out. So we support both.
And we do see that it is, as a result of that class of customer, a deeper and in some cases more extended selling cycle, right? Because this is they're not just buying a departmental solution or just small thing. I mean, the customers that go big, this requires significant consideration.
And I'll give you a compliment on asking that question about the 2 different market segment of where the VMAX replacement is and where the crowded thing is. Our experience has been every time we have gone up against the VMAX, the conversation has been a lot easier because our feature set automatically eliminates the other flash incumbents, and we have so you're right. You're right about that. With those feature sets, we are beginning to see the displacement in the VMAX area. Okay? So very quickly, I'll roll it through. We have only 2 minutes. Let me see if I can do a good job here. So we, back to some of the comments. We only buy the NAND flash chip. We turn it into the intelligent Violin memory module with a lot of our intelligence in over there to give the consistent behavior behind, Violin patented VRAID group, and your system builds up over here, and you take a bunch of them as the shelf, and you basically have the 7700 solution which allows you to scale as you go. A very quick highlight. So this is what allows us to do. You can have up to 64 VIMs in one 3U box. That's the power. And they're all hot swappable. And 1 terabyte, 2 terabyte, 4 terabyte as they keep on going in. In 3U, you're looking at the phenomenal raw capacity, add the deduplication into it, the dynamics, just changes in terms of the power consumption, the rack space, and all those things. It's, fully redundant all the way across. Array control modules are responsible for managing the health, triggering in the right kind of failover and all those things. This is where, again, we have our software running, and that's where the I/O modules set in. This is a little bit deep dive onto the hardware architecture. I just wanted to just quickly highlight that this thing has been in the market for quite some time now. Very mature, very stable. The beauty of this, again, architecture is it's not the same system which we shipped 9 years ago. We have evolved. We have evolved the NAND litho and all. We have optimized the RAID controllers. We have changed the management gateway to get the newer CPUs and all those things. And we have changed, the way the transactions happen over here to keep on evolving. So that's why when we started from 500K to 1 million to 1.5 million, and we keep going in over there. So it's redundancy built all across for the enterprise ready. Up to 16 VIMs can fail. Data is not lost, and 3 of the VCMs can go down. Your data access is not lost, and so forth.
So the VIM, the VCM is your design, is in ASIC.
Yeah.
For the other companies are using ASICs or FPGAs or
traditional
whatever.
RAID controllers. In some
FPGA.
cases, they have traditional
FPGA.
software RAID layered over.
So the only piece that you have really designed is that one, because
This and this.
and this and this. Okay.
So this is our own, and the fabric that connects them. And then, so this is the system architecture, right? So the way when it was put together, and this is what excited me to leave Intel and come and join over here.
What does it take to redesign or update this kind of
Through
control?
the last litho change, it was very small, and we have an abstraction layer that also helps us slide new NAND under an existing VIM design. So it was designed with that in mind.
So we control the interfaces, so the way they talk, as
So
an
we can soon expect the adoption of 3D NAND or TLC from you.
I think that's
Do you have a
really
plan?
more function of when the media is ready for mass production and can do what it needs to do. But we're certainly ready to adopt new media in a time to market, timely fashion for sure. Sorry, one thing I noticed is we're getting low on time. So certainly, if we get cut at any time, definitely want to thank all of the delegates and then the audience for their time, and then we're certainly going to continue as long as we can.
So just so walking it through, the entire pipeline, we have ability to do that. We only say 1 million IOPS, but your investment is protected. You go to 2.2 million IOPS and so forth. Since we control the IO size and all, we don't say do 4K, 8K, 32K, do whatever you want. We are going to parallelize anyways. Who the hell cares in the background? We take care of it for you.
Is that all in 2.2 million IOPS in 3U, or is it 3U plus a controller element also?
So this is okay. So today with the controller, so the point of this slide is what the system is capable of.
No, I understand
and
that.
what we delivered today is 1.2 million.
3U, but it's actually 5U because of the controllers. That's the reason I asked.
this
This
is
is
3U.
3U. It's all in 3.
That's why I want to
All
make
in
sure.
3U, all in 3U. This is nothing, in this model, the 7300 model, that's it.
Cool.
Yeah.
Cool.
And then you have the 7700, then you have all the self model coming in and so forth. Okay. So I'll let. So this is a software. Probably will have another day to go into the detail and to some of the things that you talked about. I had come up with some of the things that I wanted to discuss. Architected for this, replication deep dive.
Warning: the next event will be very much like this again. So
Okay.
that's live.
So next one will probably focus mostly on the technical, which I love to enjoy, and I'm representing a bunch of architects. My goal was if I can make you aware of what we have, I have done my job. And then the next meeting, I'll need a team of people to explain this, because hardware requires different skill set, VIM requires VCM and all those things. So all those people will come together, and hopefully we'll have a more technical deep dive. Thank you.